Our speaker tonight is Dr. Cynthia Cheung, an astrophysicist who recently retired after 35 years working on NASA space missions. She has a PhD from the University of Maryland and an AB from the University of California, Berkeley, both in astronomy. Cynthia had a bicultural upbringing and became a Christian in Hong Kong when she was very young. She's a fellow in Reasons to Believe and recently completed the monumental project of translating Hugh Ross's book, Navigating Genesis, a scientist's journey through Genesis 1 through 11 into Chinese. Please join me in welcoming Cynthia.
Okay, thanks, Kirby, for your nice introduction. I'll give a little bit more of my background because I'm so honored to have Ken Wolkemoth here today because I'm no geologist. I'm going to talk about lunar geology, which is very dangerous. In my NASA career, I'm not a research scientist. I'm an operational astrophysicist. So, which means that I dabble in many things. I know enough of some things, but not enough about a lot of things. So that's being an operations scientist to help with a lot of NASA space science mission, which has to do with multiple disciplines. Of course, my own original research was in astrophysics, and I got my degree, both my undergrad and my doctorate degree, both in astrophysics, mainly in nuclear synthesis. So planetary science was not really my field, but I just moved from one field to the other to many things. Towards the end of my career, I decided to do, education, which means training interns for the next generation of NASA scientists. And I was director of a lunar and planetary science academy. So I am just very honored to have to work with some of the best planetary scientists at that time in NASA Goddard Space Flight Center. So I began learning things with the student interns about lunar science and also planetary science. So you can consider today, my talk as a very advanced science reporter, because I learned this only the last few years. But I was amazed at how God's hand in creating the universe, especially in creating the moon, our natural satellite for Earth. That's why we have to thank God for the moon. By the way, for those, especially those of you who are with Asian heritage, actually tomorrow is the Mid-Autumn Festival, which is celebrated every year. It's the harvest moon, and there are a lot of legend connected to that. So as David said in his psalm, this is the lunar psalm. By the way, there are two psalms, one lunar, one solar. The solar psalm is Psalm 19. Psalm 8. David said, when I look at your heavens, the work of your fingers, the moon and the stars, which if you have set in place, what is man that I'm mindful of him, the son of man that you care for him? Very interestingly, David, when he looked at the moon, he said, God cares for us. So it actually shows forth God's care and love for humankind. When you look at the moon, it's not just pretty. Many Chinese poems are based on moon. So, I recited many of them when I was young in Chinese, and it's very difficult to translate those. There's a special cultural aspect to that. So today I'm going to present to you one of the Chinese legend. Many people look at the moon and think the moon, there may be somebody there, living there. And the Chinese legend, there's the princess and the bunny. The princess is called Chang'e, and the bunny is called Yu Tu. I gave you those two names, not because I want you to learn about Chinese legend, because those two names are now named after the Chinese lunar missions. Chang'e is the Chinese lunar mission program, and they're already to Chang'e number 5, which is a sample return mission. It's already successfully completed, and I will talk about it later in the talk. Yu Tu, the bunny, is now the robot. That's the Chinese robot that's moving on the moon. But from as of old, people look at the images of the moon. I know in the Western legend, there may be a man cutting down a tree on the moon. There are various things depending on which country you're from. So moon has inspired a lot of thoughts from as of old. Okay, so we often think about whether the moon was habitable from as of old. But today we're going to examine one question. Does the moon make Earth habitable? Why is the moon there? What if we have no moon? Will we be here if there weren't a moon? Okay, so today's talk, just a very brief outline. I hope I follow it roughly. The first one is, what are the requirements for habitability? That's a big word. Essentially, is what is the requirement for life? Then first you have to define what is life first, okay? The other thing is, what other moons are there in the solar system? There's a lot of other planets. We have 8 major planets in the solar system. Are there other moons? What do we know about them now? Why are we going to the moon? Some people think it's a waste of time and money to be going to the moon. What if we had no moon? And we're going to spend quite a bit of time talking about the moon formation miracle, because we still do not know exactly how the moon was formed, but we are going to go about talking about the most accepted lunar formation hypothesis today. The moon's role in making Earth habitable. So I want to present this as an example of God, the master designer at work. In creating the moon, he created an Earth that's habitable, our comfortable, nice blue dot that we're living in here today. Okay, so just a reading. Kirby already introduced one of them, the latest book by Hugh Ross, Designed to the Core. Chapter 13 is on the lunar interior. Essentially, I use some of his idea there, and also in Improbable Planet, in chapters 5 to 7, he already presented the lunar formation scenario. I always kid Hill when I saw him. I say, you wrote great books. However, I got great pictures from NASA. So there are a lot of nice pictures. By the way, all the NASA pictures are public domain. Your tax dollars pay for them. So you're free to download them. There's certain requirements that you're not supposed to use them for commercial purposes, except for by permission, but you're free to use them for educational purposes, like today's presentation. I know exactly where to get those pictures. So you could download them if you want to. Okay. Okay, another Bible verse. God's intention in creating the heavens is recorded in Isaiah 45:18. He say, I'm the Lord God, okay, who fashioned and made the earth. He founded it. He did not create it to be empty, but form it to be inhabited. He said, I am the Lord and there's no other. So it's the intention of our God to create a place which is habitable. So we know our earth is habitable. Now, this has been presented by Hugh Ross many, many times if you look at his presentation. And in Reasons to Believe, there's such a table you can download. There are more than 200 parameters that is required. The fine-tuning parameter in order for us to have advanced life. Today, I'm only concentrate on the part about planetary system, the planet itself, and the moon itself, because Hugh has things even on superclusters, super galaxy cluster, and galaxy and the star. I'm not going to talk over those today, but you can see the number of parameters that are required. The total number is, for us to find life, is 1 chance in 10 to the power of 705. So everything has to be just right in order for advanced life to exist. And for planetary system, like our solar system, you have 137 parameters to fulfill, to fine tune. For the planet itself, means planet Earth, there's 268 parameters. And for the moon, our natural satellite, there might be fewer, but still there are a lot, 27 parameters. My PhD thesis, by the way, is a big simulation. I know how to tweak parameters in order to produce certain result, and it's not easy. Even 27 free parameters for you to play with. So for God, our creator, to tweak all these things, he has to use a lot of care in order to create a place, a nice place for us to live. Okay, pretty pictures. This is our solar system. we have asked this question. Every person in this world has asked this question. What is our place in this vast universe? Why are we here? How do we get here? Today, I attempt to answer some part of this. Our place, how do we get here? Now, this is configuring the solar system we have seen in many contexts, okay? This is what we know as of now. Now we have only 8 planets, now 9. Pluto has to be demoted. If somebody wants to ask me why Pluto is demoted, I can answer that later on. But the important thing is to note this very special characteristics. There are 4 little terrestrial planets inside the asteroid belt. And there are 4 big gaseous giants outside. And in between, there's these what we call leftover debris, from planet formation. There's asteroid belt, there's a Kuiper belt. So there are 2 belts in between. Crossing the belt for artificial satellite is very dangerous. That's why the outer planets satellites that are sent by NASA has to have shields to prevent them being hit by many objects in traversing. There's always high risk in traversing these belts, which have lots of debris. Okay, but the one thing to notice, remember this picture of our solar system, they're very different from exoplanet system we have discovered so far, the last 10 to 15 years. The science news is always, you always hear once a while, oh, we discovered another exoplanet. I'd show you just a couple of examples. These are all Kepler 62, Kepler. Kepler is a mission that's designed to specifically look for exoplanet. And they found a lot of them, okay? That system just focus on one part of the sky, do very deep exposure and try to find out the nearby star if they have planetary system. And by golly, they found a lot of them. I'm going to show you a chart later on. But the configuration of these planetary system is very different. Now, this is our, now the lower one is our solar system. You see this one. They are only big gas giants, only one little guy. So it's different than ours. Kepler 47 have only 2 big guys. Maybe they're little ones, we could not see them. But again, it's very different than ours. The one that seemed to be closest to us is Kepler 90, but still, they have only 2 gas giants. It's just different, okay? We have not, the holy grail of exoplanet research is to find an Earth-like planet. Up till today, we have not found a single one that's exactly like Earth. So Earth is very unique. Okay, here's the planetary count. By the way, if you're really interested to follow this, you can go to NASA's Exoplanet Archive. They update it very frequently. This count, I just got downloaded this 9 days ago, 10 days on August 30th. That's the latest count. These are the confirmed planets, over 5,000 of them. And some of them, they only found 1, okay? If they do more analysis, more data analysis, they may be able to find more. There are at least 833 multi-planet system, the solar system and multi-planet system. We have more than 1. So you may wonder, how come there are these spikes here? This is when Kepler released the first batch of discovered confirmed planets. Kepler itself was launched in 2009. There's a lack in data analysis because they have been very careful when they announced the discovery. Before, there were really very few planet discovery because they're all ground-based, and it's very difficult to analyze those. There are various ways to find exoplanet. These are the different ways you can see by the color scheme. Before, very few are found by imaging, by the way. It's very difficult because the parent star will completely block out the planet. So they normally has to have some kind of coronagraph to block out the major star, the starlight from the major star before you can see exoplanet. A lot of them are found by timing variations, by spectroscopy, by microlensing, by radial velocities. By spectroscopy, radial velocity is the most common way of doing it. Astrometry is very few of them. Those are the nearest one you can find it. And sometimes they only found the disk, and by the disturbance in the disk, by the kinematics, they deduce that it ought to be a planet of such a size, okay? A lot of these pictures are exact false color picture or artist's conception. So far we have found that many. The Exoplanet Archive is very nice. They have these pre-made view graphs you can download, okay? Now here, other Exoplanet Archive, just grab a bunch of them. There are many others if you want to go online to search for them. Very pretty one. They try to be as true to the true color as possible. As you can see, there's not a water world like our Earth with cloud cover. The nice blue dot you don't find. Okay, then we come to the requirements for life. When we're searching for life in other places, we have to define what we are looking for. At one time, people just say, well, we follow the water. When there's water, there ought to be life. Oh, it's not that simple. So Chris McKay, who's a planetary scientist and also actually he called himself an astrobiologist, he's trying to define life and trying to find out by comparing with Earth, what are ecological requirements for life, such as we find on Earth. Temperature is very important. For liquid water and temperature, the two are correlated. I can give you permafrost. You won't be very happy there because you need liquid water to drink. And you have just give you those two, it's very difficult. You need light and you need photosynthesis in order to grow food. You need oxygen to breathe for advanced life. You need nitrogen because it's a fertilizer. The other thing is if you know DNA at all, besides carbon, nitrogen is an important component. These are a life is based on carbon, nitrogen, and oxygen. It's very important. So he just singled out some things that we need to look for. You want to look for life. And you might have seen this chart on habitable zone around a planet, around a parent star. You have to define where you can locate planets about a star like our sun. Here's another close by star. They think they have found planets around. So they say, what is the zone we can define life? In our solar system, we know there's only one planet that actually supports life, which is Earth. Because there are a lot of speculation about whether Mars has life. This is habitable zone was, by the way, was defined by just water, liquid water. You can see Mars is really on the edge because Mars is so much further away from the sun than Earth. They may say you may find liquid water, but water you find on the surface will be frozen. It's very cold there. And they are still speculating whether there's ocean underneath the surface of Mars. But then right now, as of today, we only know one place we can find life, which is Earth. That one and only example. They have speculated other places like another moon, which like Europa, which might have life, but it's still very far away. So it might be a completely different kind of life. These are things that are on the edge of the habitable zone. But if you read Hugh Ross' book, he has defined at least 7 or 8 what they call habitable zone, besides based on liquid water. In order to have life, you need to have the correct tilt of the planet. That means in order to have seasons, you need to be facing your parent star with the correct orientation. Otherwise, you'll be either be cooked or you'll be frozen. If you only one face facing the sun all the time, you'll be very hot. Like Mercury, it's not a very habitable place. Besides being very close to the sun, is very, very hot. There are other planets where the obliquity tilt is not stable. Like a lot of the large giant planets, they wobble around a lot. Not to mention being dizzy. You don't know how to respond when it wobbles so much from month to month, and the rotation ought to be stable. Not all the planets have stable rotation. Some of them vary a lot in a short period of time. The other thing which in climate change, you know about this ozone. Ozone is very important to protect life from damaging ultraviolet rays. People worry about the ozone hole being developed because we depleted the ozone in our Earth's atmosphere. But without ozone, life will be completely cleaned out. That's why in Mars, they don't think there will be life on the surface of Mars. There's no ozone protective layer. There's no very thin atmosphere. There's no ozone on that Mars atmosphere. The surface of Mars is sterile for all that we know. But you do not want to block out all the ultraviolet light because you need ultraviolet light for photosynthesis. So there are many zones that you need to define in order to have life as we know it on Earth. So there's the next one is astrosphere, which means connected to the magnetic field. You need a magnetic field in order to survive. I'll explain further on this. These are points that I will go over this introductory slide to tell you some of the things we need to have before you can really sustain life. It's not just water. You need a lot of things in your environment in order for you to have a stable environment to sustain life. Okay, this is another title picture from my astrobiology institute in Garden. The artist tried to combine a lot of things in this picture to signify why is Earth wet and alive. You notice, because there are a lot of molecules, the DNA and all that, they try to do in there. There's asteroid impact in delivering things to Earth, mainly liquid water, and there's the spectrum, there's the light. One thing, they try to tell people there's a hand holding up the Earth. Although we try not in the government, we're not supposed to talk about religion. Somebody sneak that in. Can you tell me which hand that is? Is your left hand or right hand? You look carefully, this is the left hand, okay? This talks about the homochirality in life. So we sneak that in, okay? We don't know why. I know Kirby has talked about that before about DNA, about life. All life on Earth use left-handed, okay, protein. That is something we can figure out because I'm no biologist, but I just let you know. Earth itself is really rare. And two geologists wrote a book just based on geology. There's a book named Rare Earth. By looking at all these things, if you do a lot of comparative to geology, you realize Earth is a rarity in the universe because you look at so many aspects of it. We are very, very unique. Okay, oops, I jumped too fast. So today I'm going to talk about the moon played a very vital role for Earth's habitability. So what if we had no moon? Some very obvious things. The dark, moonless night. We have no natural light. You can walk. Nowadays we have electricity, that's fine. But in once upon a time, in a darkest moon night, you don't want to go outside too much. No romantic poem, no eclipses. Whenever I see eclipse, I really thank God because he's the master designer gives us a lot of beautiful, beautiful scenery to look at. I'm going to go into that later on. There won't be an atmosphere on Earth. There won't be anything for us to breathe. There won't be a season. There won't be a tides. Many of you already know from school that the moon is the object that causes tides on Earth. The tides in the ocean. there won't be a magnetic field, and there will be natural shield against frequent impacts for those asteroids and comets that comes around. So the grand conclusion, this is just a grand summary, there won't be no life if we have no moon. So nowadays, when they search for exoplanet, they say you don't just search for an Earth-like planet. You have to search for a planet not to have a moon, just like our moon. Those are the better candidates. If you don't have a moon accompany that planet, it's unlikely. Based on our example of one, if you don't have a natural moon like us, you likely won't find advanced life like Earth life. Okay, about our solar system and the moons in our solar system. What's so unique about the moon? This is drawn to scale, okay? This is Earth. Oops, jump too fast again. This is our moon. This is drawn to scale. Can see Mars, the two satellites, Phobos and Deimos. You can barely see those two dots. It has the largest size relative to its parent planet. Now you can say Jupiter, Saturn, Uranus, and Neptune. You only see the satellite. If you were to draw these, this will the size of these large planets will go up to the ceiling, beyond my computer monitor, beyond everything. Because the relative size is so much bigger. These are little dots. If you draw Jupiter like the Earth size, you could hardly see that. For Mars, you can still see the dots for these two little ones. So Moon is very unique in the sense it's it's the largest satellite compared to its planet Earth. So it could do a lot of effect to planet Earth. Now these, talking about tides, these little guys will not be able to cause tides in the parent planet because they won't have enough gravity. Mass is everything. They have so little mass, just being such a little disturbance, they could not cause tides, tidal reaction in the parent planet. Okay, about eclipses. It's amazing how God arranged, put Moon in a place where there could be lunar eclipse and solar eclipses. You can say it's a coincidence, but it's just too far a coincidence for it to be just, it just happened, no. The Moon and Sun axis stand the same angular size in our sky. That's why you manage to have total solar eclipse and total lunar eclipse. The other little satellite in the other planets, they also eclipse, but then you will see a little dot across the planet disk, but you will not see spectacular eclipses like we see on our Earth, because anybody has taken science in high school, you would have seen these two configuration picture. The solar eclipse when the Moon gets in between the Earth and the Sun, and the lunar eclipse is when the Earth's shadow, you get in between the Sun and the Moon, and the shadow is cast on the Moon. And depending where it's directly covers or whether it's partial, so you can have these eclipses, and they're very spectacular when it shows up. This is the super flower moon, blood moon eclipse that happened last year. It's a blood moon because during eclipse, you don't have direct reflection of the sunlight. So you only have a multiple reflection of the sunlight. So when it's reflected multiple times, the light becomes more red. And that's why you have red sunset. In daytime, you have blue sky, but in sunset, you have a red sunset. The same reason for during an eclipse. We have quite a few blood moons this year because the moon is very close to Earth. We had the last blood moon, I think, for the last full moon. The harvest moon turned out not to be a blood moon, but still very spectacular. I looked at the moon last night. It was very beautiful. So you should go out and look at the moon after this presentation tonight, because it should be already harvest moon, at least in China. That is. Okay, why go to the moon? Why waste all the money? At one time you say, why don't you spend all the money to feed the poor? And on Earth. There's so many problems in the Earth. Why spend so much money to go to the moon? There's a very good reason, because we don't know Earth's early history. We have no record of Earth's early natural history. It's all washed out because the Earth has an atmosphere. The Earth also has plate tectonics. Things can be completely wiped out in maybe tens or even hundreds or even thousands of years. Nothing is left of the early Earth history. However, because the moon has no atmosphere, there's no erosion from water, from wind blown and all the stuff, it preserves the solar systems and Earth's early history. It's just like an archive. That's a scientific reason for us going to the moon. Besides, in the 60s, it's more political drive with the Cold War that say, well, we want to get to the moon first. There are other reasons, but the real scientific reason is that we want to go there. We want to find out our history. How was Earth formed? We don't have any record of what happened because the rocks and all that are all gone. We don't have very old rocks on Earth. Ken can tell us more about that next time when he talks, because there are very few original rocks on Earth. They're all eroded and gone. So actually, like Jesus said, the stones will cry out. The stone tells a story, and we want to get to those rocks. And that's why the moon rocks that are retrieved by the Apollo astronauts, are really a national treasure. They are all being archived in Houston under environmental control condition. Not all of them have been analyzed yet, for good reason. They keep in a vault because, back in the 60s and 70s, we don't have today's scientific instrument. They're better spectrometer, better measurement, better analysis technique. So you can write a proposal and ask to analyze some of the moon rocks. If it's a valid proposal, they will let you have it. My intern is a program. We have asked for some lunar just dust to analyze its magnetic property, and we got them. But we have to return every single bit of them. Whatever we have done to it, everything has to be returned back to it. So, but it's a very important record. You can get a lot of information from the rocks. And so today we're going to talk some more about what the rocks show us. Okay, Apollo was almost 50 years. No manned mission have gone back to the moon since the end of the Apollo mission. But the United States is planning to return to the moon because this is target date 2024. Now it's 2022. If you have paid any attention to the science news at all, we were trying to launch Artemis 1 rocket. Actually, a few days ago, unfortunately, the rocket leaked. So they scrubbed the launch 3 times and they passed the window to launch it. So the earliest time they can relaunch it will be in 2 weeks, late September. If you want to watch that, you can watch that in the news. They're trying to launch the first stage. It's an unmanned mission first. The Artemis program is different than Apollo in the sense that they want to establish more or less a permanent presence of human being on the moon because there's so much to study on the moon. We have not gone to many places on the moon. Apollo just got to the near side of the moon. We haven't gone to a lot of places, only to the flat area facing Earth for a lot of reasons, operational reasons. They cannot go to the backside of the moon at that time. Although we have sent a manned satellite to actually map the backside of the moon. The Chinese have landed during the pandemic in 2020. The Chang'e 5 spacecraft will return a sample from the backside of the moon. Okay, they have not released any data to date. And because lately the United States was not the best relationship with China, so they did not get any support from the United States, but from Russia and from a number of European countries. So we did not share the data. So there are very little scientific data released from that Chinese mission, although we know they have a different sample of a different place of the moon. Because the United States, for the Artemis program, you can read all about it in the NASA website, is having a gateway concept, is that there always is a orbiter orbiting the moon. They would send astronauts occasionally via lander to go down to the surface and do the scientific experiment, but they will come back out to the orbiter. The reason is because it's actually, the moon does not give you any protection at all. We'll go more into that. It's not safe to stay on the moon if anything happens. So they want to have what I call a maneuverable place. What if there's a solar flare? You can fly the orbiter to the other side of the moon and get protection. If you are on the surface, you're stuck. You can't go anywhere. There's no protection. I can go more into that later on. So this is a very different mission scenario than in Apollo days. The Apollo astronauts were on the surface of the moon for at most 3 or 4 days, and they are back. The whole mission is ended in a matter of 2 weeks, including the transit. But for a long-term presence, they could not afford to have astronauts down on the surface of the moon for too long, because there were a lot of risks. So the prior mission, before you actually send a person to the moon, because test out the rockets, test out the orbiter, test out everything unmanned, and the earlier unmanned mission would drop supplies to the surface of the moon, let everything be ready, you drop all the supply, and then the people will land and do things with the supply. So that's the new, what they call the gateway concept. But they plan to have a long-term presence, and they just announced the possible landing site. This time they're not going to the near side. They want to go to the poles of the moon where they supposedly, they say there may be water. So they're going to the South Pole region. They already announced the possible landing site, I think, a week ago. You want to look at the science news, you'll find out exactly what that is. That's the South Pole Icon Basin, where they find the likely permanently shallow region where there may be water. So that's the United States plan to go to the moon. If you want to go to Google, you can even find a Chinese plan. I think United States, if the plan goes right, they will land the person on the moon ahead of the Chinese. But we don't know, because they are pretty tight-lipped on the other side. So we don't know what their plans are, whether they're successful or not, we don't know. Okay, they say, at least we know for sure they have returned one sample from the far side of the moon. Okay, what do we know from of the characteristic of the moon so far? Now, these are not just by Apollo missions. We are continuing doing research on the moon, caused by telescopic observations, by a lot of scientific analysis, by imaging, by spectroscopy, by photometry. Because Apollo left a lot of scientific instruments on the face of the moon. And so we have seismometer on the surface of the moon, so we can even monitor moonquakes nowadays. We have a lot of things. There's a laser reflector on the moon. That's why we know the accuracy to the distance of the moon better than many other things. We can do the laser reflection down to the millimeter scale. We know exactly how far the moon is moving away from us. So that's extremely accurate. We know for sure there's no water. We have heard about water on the moon, but I go further into that later on. That's not real water, by the way. Not the kind of, you can't even get a drop from the whole surface, okay? It has no nitrogen and carbon. That's from some of the moon rock analysis. They're deficient, not completely silage, but they're very deficient. From the seismic data, there's magnetometer, there's a seismic instrument there. We deduce no iron core or very small iron core. There's not enough to set up a magnetic field. There's very few iron companion or sidereal elements on the moon. They're very deficient. So it's different than the composition of Earth. Also, they're very deficient in volatile elements, because no oxygen, no hydrogen, there's no atmosphere. Okay, they're all gone because of its gravity. You need to have enough gravity to hold on to these volatile elements. And moon itself being so small, it will be blown away by the solar wind in no time. It's not a very hospitable place. So based on that, you would say the moon is not habitable. You really feel for the astronauts. Daytime high, 224 Fahrenheit. A few days ago, we were on a heat wave. It's 110 here in the Bay Area. You're already cooking. You wouldn't want to be 224. Even with astronaut with a cooling suit, it's not fun. The nighttime, negative 244. So it's very tough. You got to be able to stand that kind of temperature, even with the spacesuit. Okay, so how do we think the moon was formed? In the days before the Apollo, you're welcome to wave your arms, the scientists, and say whatever you want. Of course, they're pretty educated conjectures. Since we know there's protoplanetary disks from observation of other places, the Earth likely is condensed from a protoplanetary disk. So when they form, maybe they form together. There's just another extra hunk next to the Earth. So that's pretty nice, okay? But you got to have evidence to support that, because there was nothing at that time, okay? You can't even define what that means. The other thing is fission. So you got the two hunk, one of them separate by some mechanism, okay? But the dynamics very hard to work that, and they think it won't work. The other thing is capture. A large body can always capture a little body. That's what they think the two satellites of Pluto were all captured by Pluto. It works if in the right dynamics, it works. But these are all hand-waving arguments. There's some data for and some data against, and there's no definitive answer. Okay. Then after the Apollo lunar rock samples came back, there comes around this development of the giant impact hypothesis, which is now the most accepted hypothesis for this lunar formation, for many reasons, because it explained a lot of the characteristics of the Moon-Earth system, both the dynamics, the structure, the abundance, and a lot of things. And some people dub it the big splash. It's not the Big Bang, but this time it's the big splash that formed our moon. Now, so what is a big splash? Sometime about 50 million years after the formation of the proto-Earth, Earth has not really formed completely yet. It's what they call a proto-Earth. There's an impactor. They call it Theia, okay? That somehow collided with Earth. And then the two thing, depending on which detailed theory you follow, might coalesce. One may knock the other thing. Some theories say the two may pass through one another. Anyway, there's a huge mix. Anyway, both bodies completely heated up. You can say they're almost destroyed, and they got splattered out. At least most of the theories say the Earth largely remained intact. There's some exchanges of material between this impactor and the Earth. And finally, you end up with two bodies, the Earth-Moon system. Now, this is not just hand-waving, because nowadays we have huge computer systems to simulate. We don't know our past history. We put in educated guesses, we can simulate what happened in the past given the right initial conditions. That's how we do scientific experiments on the computer, and we can speed up the time. We know exactly what happened. Now, this is all supported by computer simulation, putting in all the correct physics, all the dynamics, including theory of relativity, all the correct abundances. What we know about the solar system abundance in general, because we think this impactor is in the solar system in order to have roughly the solar system composition. And we know what the composition of Earth right now is. So that you can speculate about what the impactor is, but we know pretty well, to a certain degree of uncertainty, what the Earth looks like. It's right underneath us. We're sitting on top of it. So there only that much you can, maneuver in terms of free parameters. Okay, this is actually it's not the printout of some of the simulations, and with time running, originally when it impacted, the material got drawn out. Okay, Earth solid roughly remain intact, but it's completely molten anyway. There's some exchange of material, and then material that got dragged out, completely circulate the Earth. After a while, it go into what I call proto disk, and this eventually condensed to form the moon. So this is the leading hypothesis now about how moon was formed. Now I have to go back to a bit of history about how they analyzed moon rock before I can give you the evidence of why they trust the moon rock so much. This is part of my last assignment in NASA. Before the Apollo astronaut went to the moon, they are the early astronauts. You see the movie The Right Stuff, they are all fighter pilots. You can say they're scientists somewhat, but they have no geological training. So you got to train them. What do they look for when they land on the moon? So I was really fortunate to be able to enlist a geologist to take my interns in 2009 to visit the astronaut training place at Sudbury in Ontario, Canada. This happened to be astronaut training ground. This is John Young and Charlie Duke, the two Apollo 16 astronauts. That was how they looked like in the 60s. There's no iPad. They're looking at the geological notebook when they're walking around. Okay, these are old-fashioned cameras. Okay, they will teach them what to look for when they land on the moon, what to see, what to pick up. So we went to Sudbury. Sudbury is also known as the nickel town. It's a mining place. We took the picture underneath the big nickel. This is me here on the left-hand side. This is the geologist, Paul Lohman. He has already passed on. At that time, he was in his 80s. And we took a bunch of interns, very smart guys, all of them. Most of them has already gotten the PhD by now, by the way. At the time, they were just either early graduate students or senior undergraduates. And so we tried to duplicate the 3 days of Apollo 16 by walking around this impact basin. Sudbury is an impact basin. This is really across the border, somewhat I think it's about 400 miles or 4 hours drive from Toronto. I forgot which. So it's a nice town to visit to see the geology. It's a very complex geological complex. There are a lot of argument whether the whole thing was created by the comet impact or meteorite impact, or whether there are other volcanic activities, a lava flow there. So it's not that easy. But there are a lot of rocks that show you what impacts mean. Because at that time, they're not sure all the craters we see on Earth, on the moon, whether it's volcanic craters or whether it's impact craters. We have no way of knowing. You just see these holes and mountains on Earth. So what they're looking for? So they teach them what they're going to look for. We have to start from the lower right and go all the way up. The regolith, the shattered cones, the breccias, and ultimately the creep comes back much later on. When they first landed, there was worry at that time. With the astronaut, the moment Armstrong stepped on the moon, would he sink in a few feet of, I don't know what kind of sand or dust? You don't know what that is. That's what they call lunar soil, regolith. It turned out those are nasty stuff. The moon is actually being gardened, as the lunar scientists say, by micrometeorites hitting them because there's no atmosphere protecting them. So all the rocks are broken apart to little bits of pieces. Lunar dust is not something fun. They are sharp. They are really a nuisance. It's much worse than Earth's dust. You have recording of the astronauts, what they say on moon. The only time they cuss is about these lunar dust. They wedged into the instrument, wedged into the gloves, so they can hardly move their fingers. It's very nasty stuff, but they don't sink because they're really glassy kind of beads kind of stuff. Okay. The best thing they did, according to geologists, at the end, they don't know what to do. They just scoop out a whole bunch of them into the bag and just take it back in the lunar model and fly back. And those are the best things they have, because they're very useful material, because they couldn't pick up too many rocks, by the way, but they scoop out a whole bunch of lunar soil. The thing that they ask them to look at and train them to look at is whether if it's an impact, there'll be shattered cones. You see those grains here, okay? They pointed at the place where something hit, and then the rocks got thrown out, and they will have this kind of striation on the rock. There's some kind of signature there. So according to Paul Lohmann, the geologist, say, the moment they landed, they come back and told him, I know these are shattered cones and they're breccias. Breccia, the semi-conglomerate, something molten and then incorporate all the bits and pieces, whatever that was originally in the bedrock. So there's the specific signatures they're looking for. And they say the astronaut, the moment they step, they look around, they say, I know what this is. This is not volcanic stuff, because the place they landed, they say, this is an impact site. They're breccia and shattered cones. And they recognize it immediately. They have been trained in Sudbury. And they say, okay, so we pick whatever. Now the creep, the much later thing, after they come back and do the analysis of the composition, the creep is an acronym. It stands for K is the chemical potassium, REE is the rare earth elements, the rare earth, okay? In the periodic table, P is the potassium. After they do the analysis, they found out a lot of the lunar rocks, including the regolith, contain these kind of composition, which is kind of rare. You don't find these things on Earth that contain such higher concentration of these rare earth elements. Rare earth is very important for high-tech industry. Your cell phone, your SIM card, they all contain these things. Now, this is much later in picture. There's nothing to do with the Apollo program, but it was taken by a lunar prospector satellite by a gamma ray spectrometer, trying to find out the distribution of this called creep. At first, there was this theory about it being all over, because it's all over the regolith, all over, maybe a layer completely underneath the entire moon that consists of these elements. But the lunar perspective, but by the way, these are a lot of them are radioactive. So the gamma ray spectrometer actually looked at the radioactive thorium, and they took the pictures. Here's the near side of the moon, here's the far side. And by golly, they're not evenly distributed. They concentrated on this place, the lunar highlands. That's a bit of surprise. There's a specific concentration in two areas. And that's the places they say maybe we should go to next. That has to do with lunar resource utilization. Nowadays, there's additional reason to go back to the moon. We don't just go there for, now that we know somewhat how the moon formed and we retrieve some samples, we go back for specific resources, natural resources, which include these guys. These are rare things. What if we exhausted the mines on Earth about this rare earth? There only fixed amount resources on Earth. Why don't we go to the moon and harvest some things? So that's an additional reason. And they say the Chinese, they really want to get to, although they have one of the world's largest deposit of this rare earth elements. They say it's not like, there's a limited amount. When they will exhaust them, and high-tech continue that way. So that's one reason so the Apollo program help us to actually define this big splash, this lunar formation theory. Okay, now I'm talking about what this impact did to make Earth habitable. Number one, in the proto-Earth, as Genesis 1 said, in the beginning, everything is dark, okay, and void. Hill's interpretation is everything is really, we have somewhat of an atmosphere, but it's not translucent. You can't see anything through it. That's why there's no light. In the beginning, the Earth itself is dark, okay? So after this impact, it knocked away Earth's original atmosphere. So the Earth's atmosphere became transparent. And that's when Genesis 1:3 said that there be light. Light can first time hit the surface of the Earth. By the way, the cooling takes place very fast. That's the fastest estimate, say in terms of 100 years. The whole thing has cooled down and moon has formed. It's a very short time scale in terms of geology. Even for the longer time scale, it's still short compared to geological time scale. So this impact took place and the two system is in place very fast at least, and then gradually more things happen. The second effect is very important, is there's a mass exchange. Proto-Earth itself at first was not that heavy. Now, their mass added to it by this impactor. So it increased Earth's mass and density. First, just the proto-Earth, is again a conjecture that we may not be able to hold on to all the water because the volatile, it was very light element. It will all gone. That's the reason Mars is dead. Mars is too light. Mars is smaller than Earth. It cannot hold on to this water vapor. And we need water vapor, but there's no water vapor. But today, Earth can hold on to its water because we have the right mass. Now, the third thing is the tides. The tides are, well, this is an animation. You watch it carefully, it moves around. This is the work of gravity. When two bodies, one is relatively massive, like the moon is not that much smaller compared to the Earth, relatively speaking, compared to the other moons. It can actually distort Earth. So Earth is not really exactly round, especially with the ocean. So the ocean has more tides. So essentially, it becomes flattened, like as if there are two handles there. So like a skater, if you push out your arm, you slow down. So you gradually slow down Earth's rotation. When Earth was first formed, it's a lot of this angular momentum calculation. Earth is spinning very fast. I'm going to heal at one time, maybe 6 hours per rotation is too fast. You can't stand there. You will be dizzy. This is again a theoretical simulation about Earth rotation rate, historical. There are particular times when Earth's rotation just all of a sudden slow down for where maybe a major meteorite hits, volcanic will go off, something internal sloshing around. It can cause the rotation rate to actually adjust. So it's because of moon's presence managed to get Earth's spin rates down to a rate that now is a steady 24 hours. It was life-sustaining. Now, the other thing which I didn't realize until I read Hill's book is because before the sun shone through on day 4, how can we have liquid water? It's pretty cold at that time. The sun's luminosity was not up there. The sun's luminosity continued to increase. That's why now there's people talking about climate change. The sun's luminosity will continue to increase. The reason we could exist today for a number of reasons that we got cooled. If you read Improbable Planet, Hugh goes into a lot about this air conditioning effect that human being managed to survive in this very short period of time. But during the early days when the sun was dim, how can we have liquid? We have an ocean. We see God's spirits are hovering over the ocean. How can we have liquid water? But the tide is actually a force, a mechanical force, and it actually transfer heat. And so it actually maintains the temperature for Earth. So we have liquid water in those days. So very early on, Earth has an ocean. Now, this is an important thing. Tectonic activities. Next time, Ken Wolkenhoff will talk about all these, which I know just a little bit. Without radioactive isotopes, there's very little hope about tectonic activities. You need to supply energy to blow up, for Earth to blow the volcano. The energy has to come somewhere. In the beginning, when Earth is still hot, you can understand there are a lot of heat, but now it's completely cool off. There's something that has been consistently letting out heat to get, some parts of the Earth to just blow up. And this tectonic activity is very important for life, in spite of what we don't like in California about earthquakes and all that. I always think about Hawaii, which all the rich soil, rich lava, they produce so many good stuff agriculturally. Say with a tectonic activity, you won't have this rich soil just for regular life, just because I like to eat. So I say, I need good agricultural soil. You need the tectonic activities to renew a lot of things. And in fact, a lot of geologists, the planetary geologists, still are thinking about where Earth's water came from. We lost our original water when Earth was formed by this big splash. Water has been replenished somewhere else. They say, well, in the core, when they cool down, the water has come out. There's water in the soil itself. The rocks has water. They say, well, how does it come out? A volcano does not just blow lava. There's rain. There's really this dirty water that comes out from. They say that might be enough to actually replenish today's ocean. And the other part is has to do with asteroid and comet delivery from outer space. So there's another story to it. So the radioactive isotope is extremely important for Earth's survival and for life. The sixth thing is formed with the right mass, because mass exchange, so that the moon is big enough to stabilize Earth's tilt. Now, Earth is surprising, is one of the planets that has a very stable tilt, 23.5 degrees. So we have 4 seasons. Very nice. It's not too cold in winter. You can still survive with a nice coat. But in other places, other planets, you don't want to be there. In Mars, you don't want to be there because the tilt is not stable. It wobbles around too much. If you change from the diurnal temperature, it changes too much, you feel very uncomfortable. So you can have stable climate and season in order for planting, for farming, for all that. So with a stable tilt is extremely important. Okay, now we talk about the endowment. Now this is just, again, a comic figure to tell you roughly what people are thinking of when the two bodies hit. At first, the proto-Earth in the mantle is very deficient in all these volatile elements. It has a rich iron-rich core, but not big enough. But this Mars-sized object that hit, sorry, go too fast again. It endowed a lot of things to Earth. So it gave Earth all the major volatiles. CNOSH. Those are life sustaining. That's DNA composition. Those are some of that. Besides, well, silicates. Okay, we need sulfur too. Okay. And then this Mars-sized object also endowed enough iron to Earth's core. So they say the remnant of this Mars-sized object might be sitting in the core of Earth right now. Okay, there's such a theory that says that. And in increasing enough to enable a strong enough magnetic field as an enduring magnetic field, it doesn't die. If you still have a dynamo. And this dynamo is extremely important. They say Mars dynamo died very early. Mars is a remnant magnetic field, but it no longer has one, not an active one. That's why sending people to Mars is not a fun thing. NASA I know for a fact, withdraw all the manned space flight to Mars for one very good reason. We do not know how to protect astronauts after they land or on the way. We don't know how to protect them from radiation. Radiation is extremely important. Protection from radiation. I personally know 2 astronauts myself. They are both passed away younger than I am. They're both in space. Some of you may know airline pilots wear Geiger counter because they do, their job require them high altitude flights that high above the atmosphere, they have less protection than we are down on Earth. So they actually sustain more radiation. We don't know these 2 astronauts has been in space not for too long. They're just mission specialists. They both die of cancer relatively young. So we don't know, without protection, we don't know how to go to Mars. And there's no magnetic field. The same situation with the moon. There's no magnetic field on the moon. How do we protect them if there's a solar flare? I have seen a late night movie about a bad lunar mission. There were astronauts on the surface of the moon, and they announced a solar flare. They don't know where to go. There's nothing that they could hide. You know, your solar mod, your lunar modules, this is like a car in a crash. It's just a sheet metal. There's nothing to protect you. They say it's nothing. Might as well. So that astronaut eventually died of radiation poison. I was involved in a slight project in looking for how we can have astronauts on surface of the moon. We actually look at the natural protection. We know there are lava tubes, natural holes on the moon. Mass is the best protection if you don't have a magnetic field. If you can find one of those holes, maybe then crawl in there until the flare passes. If you're on the surface, whereas you're in orbit, then you can maneuver the spacecraft, you have the whole moon protecting you. That's much better. So the magnetic field is so important. This, more detail, like an eye chart about our current abundance on Earth's upper crust. And these things is because of the result of endowment from that Mars-sized object. And in the metal all sunk to the deeper interior. And that's the current chemical composition. Okay, radiation hazard. Radiation, extremely important. We are here on Earth, we thank God profusely for our magnetic field. Once you get outside there, you're subjected to all these things. You can't do without them. They're part of the universe. Just our sun let out all these things. X-ray, ultraviolet, solar winds, solar flares. You're bombarded daily by them. If not for our atmosphere, you got fried instantaneously. Not just a sunburn, this is more than sunburn. We have Jupiter itself. It's another huge radiation source. If anybody has played with radio, we require our interns to be ham radio operators. You quickly find out what is the biggest radiation source beside the sun. Natural radiation source is Jupiter itself. Some of the particles reach Earth too. Without the atmosphere, it's not very nice. We have spacecraft. My colleagues actually did the spacecraft, Juno spacecraft to visit Jupiter. One of the biggest things is they really have to multiple shield the instruments, especially build bigger boxes to shield because they're not sure they can survive the transit through Jupiter's radiation belt, which is full of high energy charged particles. It will damage. One zap, you're done. One zap through your computer, you're done. Then no more control. Gamma ray burst is very bad. One of my colleagues conjecture, one of the gamma ray bursts closest to Earth might have initiated an event that killed some of the dinosaurs. That's the Gaminga pulsar radio gamma burst. So it's extremely high energy radiation. You only need a few and then you are gone because they cascade through the atmosphere and cause umpteen damage. These are really bad guys. The extragalactic cosmic rays, the ones that manage to get through various protection in our own galaxy, extremely ultra high rate radioactive. They call it the TeV range gamma rays. it do very high damage to your body. So it's not like your regular positron scan nowadays in the medical usage. They're much, much, much lower. Once you're above Earth's atmosphere, you're taking multiple X-rays every day, and it's not good. Because when the supernova go off, that's why Hugh says we are lucky we are not located near the center of a galaxy or a major star cluster. We don't have supernovae going off every day. We cannot sustain the radiation. So we thank God for the magnetic field. If not for this moon forming event, we won't have our magnetosphere. It's a force field. Number one, we still have our atmosphere. The solar wind itself is actually a high-speed wind that can blow away whatever gas already in our Earth's atmosphere. That's one reason Mars doesn't have much of a magnetic field. The moon lost its atmosphere very early. Whatever gas is attached to it is long gone. Even if it's lightweight, the solar wind will be ripped off. But the magnetic field protects us. So how does Earth's magnetic field protect us during a solar flare? You're all familiar with this biomagnet kind of scenario. You like to watch auroras, go to the North Pole area. Even nowadays, a big solar flare, you go to Minnesota, you can see a lot of auroras. I've been to Alaska, and it's very, very pretty. You can even hear them hissing. One of the scientists I work with, his PhD thesis, he spent his time in University of Alaska just photographing beautiful auroras. All the radiation got diverted to the poles, which very few people live there. So it's nice. You only see pretty stuff most of the time, although a few of them got so close. One time, one of the solar flares actually caused a damage to the Canadian power grid, because once it hits there, there's no protection you can plan for, and they were out. And when they know about now their space weather website, by the way, they will predict the big solar flare coming in. So for the satellite, they're operating in orbit, they actually turn their bottom towards that, so they're more protection. And for sensitive equipment, they will turn it off, simply turn it off. Then there won't be any damage. So without the magnetic field, without this endowment, we don't know what will we do. There's another thing besides this electromagnetic protection. The solar system is a very hostile environment. So you better watch out for falling rocks all the time. Early on, we look at the configuration of the solar system. There are two belts full of debris from formation of the solar system, whereas one is called the asteroid belt, because they're big asteroids, which you can see as a regular ball or hunk of rock, but they're smaller ones, the small asteroid. They can come where there's a perturbance, they will crash towards Earth. And there's also the Kuiper belt, which, of a different composition, we know, because they are much further out in the solar system. Most of the comets come from the Kuiper belt. By the way, Pluto is a Kuiper belt object. And there are many Kuiper belt objects. And that's why Pluto got demoted. They give you the answer. They discover other objects in the Kuiper belt when they flew the Horizon spacecraft towards the Kuiper belt. They say either we increase the number of planets in the solar system to thousands, because there are many objects in the Kuiper belt of similar size as Pluto, or we demote Pluto. So we have ended up with only 8 planets, because we find one time we couldn't see out that far. So we don't know how many Kuiper belt objects there were. But we flew a spacecraft called Horizons out there, and we found many, many objects, and some larger than Pluto. So Pluto cannot be a planet by itself. So, but these things, once a while, they came close to Earth. And depending where they fall, well, you're lucky they just fall in your bag and you pick it up, you might become rich, because it's very useful research. But if it came through your roof, that's not very nice. I'm not sure the insurance will pay for it, because it's an act of God, in the sense they might classify that. But you can pick up the meteorite, it might be good. But these things actually have rich resources. They could replenish reserves in the planet's mantle if they come in the right place, but you don't want to get hit in the wrong place. So what is moon dust being so close to us? It actually is our natural shield. We found that out when we compare the near side and the far side of the moon. We are so used to looking at this side of the moon because we are tidally locked. Now, we talked about tides earlier. We become tidally synchronized with the moon's rotation. That's why we only see one side of the moon on Earth. The moon rotates, Earth also rotates, but we rotate at the same rate. It's 28 days rotation. So you're forever looking at one side of the moon. You don't know what the back side of the moon looks like until we send a spacecraft to the other side. Oh, and we see it's all pockmarked, all cratered. So what happened there? What happened is it's shielding us. There are a lot of things that would crash right to Earth if not for the moon day. It took all the hits. So it became a natural shield, and this is actually using real data. This is guarded in the visualization lab. They show when each crater was formed throughout the history of the moon. And we have interns actually counting craters and discovering, because they superpose on one another. And they're actually protecting us from this bombardment. If not for the moon's presence, we have a lot more cratering on Earth. Luckily, most of the craters came here millions of years ago, killed off the dinosaurs, and then major massive extinction, and all the dinosaurs, all the things died. The next generation comes around, and finally humans shows up, and we have very few craters by the impacts by all these damaging stuff. And NASA actually has a program, has a patrol, has asteroid patrol, rather than jet propulsion lab. They actually watch where there is a near-Earth asteroid. You may hear all these space news, but don't worry, very, very few really will get through the atmosphere. Most of them got burned up like shooting stars. Most are small asteroids. So most of them broken up before they hit Earth. Now, I've gone through a lot of things, but just wrap up a little bit. The analysis of moon rock continues. And we don't just analyze moon rocks. I think as of 15 years ago, we discovered since most of the rocks came to Earth, can come directly, they follow pretty much like a magnetic field line. They land up in the Antarctica. The people, scientists in God, the Space Flight Center where I used to work, they go down to Antarctica every year to just do meteorite search. And especially they find lunar meteorites. The impacts to the moon, and they knock off parts of the moon, they came down to Earth. So that's like a automatic sample return. We don't have to send a spacecraft, they came to us. So this is latest analysis by the Swiss scientist. It was just published a month ago. This is again another confirmation of the impact hypothesis. They analyze, this is a thin section, it's very pretty. Rocks really tell a very pretty story. It's better than any graphics people can do. It's all the embedded glass. They discover that in the glass are embedded noble gases from Earth's mantle. That means at one time, Earth's moon's materials completely mixed up. How can you get from a lunar meteorite Earth's noble gas? Unless at one time, way back, the two bodies are completely mixed up. So they use that analysis to really, again, affirm that the lunar impact hypothesis is real. And then more analysis ongoing, and they're continuing being added because there are a lot more simulations besides the beginning simulation. People use different conditions, different size objects, and that theory becomes much, much more firm nowadays. And there's no competing theory to date that works. There are people who try to go back to the fission to capture all sorts of things like three-body collision. They try all sorts of things, and this is still the leading hypothesis that most people accept now. Okay, talking about potential lunar resources. We did a lot of analysis nowadays. These are spectroscopy analysis. We know that things are more abundant on the moon because we have a slightly different composition because of the endowment and a different formation. We have a lot of helium-3 on the moon simply by solar wind implantation. The helium-3 was formed on the surface of the moon. And at least rumor has it, the reason the Chinese want to go to the moon, because they want to harvest the helium-3 and bring them back. Helium-3 is a major, you cannot make, there are very few things on Earth that can get the fusion ingredient, but it's readily available on Earth, on the moon. So why don't we go there and get it? They're really material for nuclear fusion reactors, and you want fusion, not fission reactors, because once it's made into, once it fuse, become the leftover is water, which is harmless. So everybody's still trying to create nuclear fusion. They say, but you got the raw ingredient, and that's quite abundant on the moon. But how to bring them back is a different story. Okay, so this is some of the things that people are thinking of right now, the rare earth elements. Now, this is just a pie chart I got off from one paper about the relative abundance of different elements. You can see, just look at the red ones, okay? Those are things that we really like. It obviously is more abundant on the moon than on Earth. That's a story. So there are other minerals. How do you mine things on the moon is a question, but they're trying to develop things. We don't know what kind of strength of a drill you need on the moon. I have colleagues who are trying to study that, simulate various things. The rare earth is something that everybody wants to get at because we only have limited resources on Earth. And the high-tech industry want the rare earth thing, lithium, molybdenum, rubidium, all these things. They want them because you just need a little bit, but a little bit is combined with all the cell phones, all the SIM card is a lot. So these are the future things that people are about trying to go to the moon for, and maybe even to capture an asteroid. They think asteroid might have the same thing as that. There are all sorts of scenarios trying to make use of these natural resources. Okay, that's all I prepare. I just give you a few more suggested reading. You can Google them. You can go to reasons.org. Some of the blogs, they already talk about various things. By the way, all the things I talked about, they're not yet in textbook. They're all in papers. The impact theory came about just in the last 15 years. I didn't know about that when I was a graduate student, not until I worked in NASA for some time. Science magazine has a lot of things like that. Oh, videos. You're tired of reading papers. Robin Canute's collision that formed the moon is a very good one. Moon 101 in National Geographic is very good. It's an hour long. So you can go to YouTube and if you have nothing better to do for the weekend, you can look at those. Evolution of the Moon is also very good. They do a lot of things. There are a lot of crazy video, a lot of conjecture, what happened. They did some very nice one about what if we had no moon, about things crashing together and the tides all died and there's no fish, no nothing. Anyway, so that's the end of my talk. Thank you for your attention.
Wow, I'm exhausted. That was really some tour de force, Cynthia.
Yeah.
I'm just amazed at how much information you conveyed, and so much of it I had no idea. So I'm going to open this to questions. So have at her with your questions. Anybody want to start?
Yes. May I ask?
George? Okay,
yes.
Go ahead.
Doctor, I wanted to ask you the Chang'e and the U2. Can you tell me what those two represented again, please?
Okay, the channel is the mission name itself because that's the princess. It's a
Prin-
legendary figure. That's the name of the entire program. The channel 1, 2, 3, 4, 5. Now it's 5 already. There's 6 maybe the manned mission from China. The U2 is the robot that they took with them.
Oh, okay.
The robot they left on the moon surface. The first U2 was very bad. They said it would hop. It didn't move. It got stuck. Okay.
I
It
think I
tells you how
remember that. Yeah.
the first one, they said it just managed to take a still photograph. It didn't move anywhere. But later on, they managed to move the other robots. And the
Right.
drill, they didn't reach its. They claim it can dig 2 meters into it, but they end up digging with 6 centimeters, something like that. Because I know it's not easy to do the drill. The Curiosity drill, by the way, only digs a few centimeters. I work with the guys who was formerly my intern who command that drill. It's not that easy. They do multiple simulations before they do one drill. So the operational aspect is very difficult. It has to do with the Chinese culture. I go on ends about that, how they cannot do operationally well. I understand the culture. That's why I think the United States is one of the best places with why the space program can go forward. There are a lot to do with the cultural aspect of it too.
Fascinating.
Yeah.
Thank you.
It looks like Ken's got his hand up. Ken, do you want to go ahead with unmute yourself and ask your question?
Cynthia, you nicely described why the moon gets that reddish color called the blood moon. Could you kindly just review those steps again? I'd like to get them more clearly in my mind.
Okay, just like a sunset. Why do you get a red sunset? In the daytime, you got a blue sky. In the nighttime, evening sunset is reddish because the number one, the path of the light from the sun goes through a longer distance, or they get reflected multiple times. So every time you get reflected, the energy decreases. So you can say it's a redshift. I don't want to use that term, but then it's actually get the energy lower, so it actually redshifted. So in an eclipse, you don't get direct reflection from the sun, because normally you see a bright moon that's directly reflected. The sun shines on it. But when it's eclipse, so it got reflected light through the earth. So it gets at least a few more reflection before it hits the moon. So it's much longer wavelengths. So it becomes reddish. It's almost invariably bloodish when you get or pink even in some of the more distant lunar eclipse. But I have photographed just by a little instamatic camera blood moon just outside my garage, getting up in the middle of the night. And it's really red. Now, through the naked eye, it's even more dramatic. Next time the blood moon come around, when you see the news, go out and see it. It's quite spectacular. You say, what a sad thing. And it's just like a big lantern, especially it's close to, the picture I show you, that one I think is taken by Brazil when it first rose the moon. It's really dramatic.
So it's particularly when the moon is near its initial rise or setting.
Yeah, it goes to more of Earth's atmosphere. So when you see the moon, the light from the moon also goes to more of the Earth's atmosphere, so even more red.
Okay, so it's through the atmosphere, just like the sun. Okay, all right.
Okay.
Thank you.
Other questions? Anyone else? I've got a couple if nobody else does.
I have a question.
Go ahead,
Cynthia.
Kirsten.
The group of interns that you took to Canada, what were they collecting again or looking for? Were they looking for what you presented on the next slide, which was the lunar soil and the shatter cones? Were they able to find things like that at that site, or maybe I missed something?
Yeah, we found things because there's an impact crater. because we don't collect anything. We're not supposed to collect. We just look and observe. Of course,
Oh,
we don't pick anything. It's because I don't think they mine because it's just a mining town. They break apart the breccia, but we went with geologists who were trained astronauts, so know exactly what site to stop. It's a huge area. We actually rented a bus and we went around, and he told the bus driver where to stop. This is the place where you see the breccia. It's just an old rock on the road. Normal people would just pass by, they just road cuts. So what's so special? But unless you know what to look for, you may say just road cuts. So what's so special? And geologists,
right.
I think Ken can testify to that. Are crazy about road cuts. When they build a road, you go there, you go after them, because the first time you cut over the mountain, you want to see what's in there.
Oh, yeah.
You don't have to think yourself. So they go around and look at those things. The thing that I was really bummed because we arrived a bit late. The mining, there's a mine that allow us to go down. They already closed for the day. I was really so unhappy. We were going to go down the mine and see. It's just it's no longer operational mine. We have all the things for us to see how they mine the nickel. There are a lot of controversy whether nickel comes from the sky or is actually from the ground. A lot of people say it's endowment from heaven. That's the
Oh.
nickel. That's why the city's logo is nickel, the big nickel. We took the picture under the big nickel.
That makes sense. Oh,
Yeah.
interesting.
So, but there are veins of nickel. They say, well, whether it revealed by the impact or whether it's, it just came from the heaven, nobody knows. Okay, it's very controversial. The geologist studied that area for many years. He has papers on that, but that's the way. That's still ongoing. If you're interested, you can go to Canada Geological Society. They have an entire booklet on that. I think it can be freely downloaded. They're still studying that area.
Kirby, I've got a question.
Go ahead.
You mentioned the possibility of mining things, bringing material from the moon back to Earth, resources that are limited here. And wouldn't that decrease the mass of the moon and hence its distance from the Earth, or would it be just insignificant?
I don't know how much you can bring back.
It'd be pretty limited, I think.
That's just a minuscule amount, Of course, we're not taking half the moon. Because there are people who, they're fantasizing. They're thinking about capturing a small asteroid. Small meaning like a hunk, like, I don't know, maybe a size of a large spacecraft. There's asteroid of that size. If it's the right composition, you will solve the energy crisis or whatever, okay? You have to find the right asteroid. They think about that. But asteroids sometimes are very large. We can land a spacecraft on an asteroid. The asteroid is very large. It's small things. If you capture the right one, you capture a diamond one, that's one thing. You capture, I don't know, a thing completely thorium, you'll be very rich. So depending, but the problem is that when asteroid comes around, how fast can you determine its composition before you do the operation? Operationally, it takes forever to have the right orbit to send something up. That's why the operational obstacle is not easy. That's why I say, how about rescue mission to people who are stranded on outer space? Like you have seen the Martian movie, all these crazy things. It's a lot of fantasy. That's one reason the Artemis mission do not want asteroid on the surface of the moon. What if something happens, somebody got sick? How do you get them launched from the moon? You have to spend a fuel to launch somebody from the moon to rendezvous with the orbiter, and the orbiters had to get all ready, all wrapped up and move back to Earth. So it's not easy. So, and talking about rescue from Mars, forget that one, okay? I asked my intern, you want to go to Mars? Everybody say yes. And I say, what about it's a one-way ticket? Then, no words, because we don't know how to get somebody back from Mars.
Yeah.
Not yet.
Kirk, did you have a question?
Actually, I had a comment. Just a big thank you, Cynthia. It was fascinating My mom, who is 90, had a really, really hard day, did not rest. And yet I was translating to her and she was fascinated and she kept wanting to stay to hear you. So thank you.
Maybe you can let her hear the recording later on when she feels
Yeah.
better.
Yeah, I'm
there-
still recording it. Next,
Yeah,
anyone else have a question before I
I was
ask
gonna
mine?
say, there was a question in the chat from Doug Kyle about when Cynthia's translation of Hugh Ross's book is going to be available for purchase. And also he's looking for apologetics resources for Chinese, well, science-oriented Chinese. And Cynthia, there's one I've heard of, I think you recommended before, a Song of a Wanderer.
Yes,
And is that,
it's available.
yeah, I found it. I'll stick the link in the chat box here. Is it, and I found it for free somewhere once. If you hunt around, you can find a free version on the line. But
You can go to, excuse me, it's go to Ambassadors for Christ. It's
Okay.
in Pennsylvania. They have discounted resources for evangelism to Chinese. And the Song of the Wanderer, you can get the small booklets, I think 50 cents. They can even, if you're doing an evangelism meeting or something, they can even give you a whole bundle. I have it somewhere on my shelf, I can grab it now, but we usually give them out in big meetings to anybody who wants them. It's a bit outdated, it's 20-some years old. The
Is it
scientists who
science
wrote-
solid? Is the science good in it?
Yes, he quoted Hugh Ross. I know the
Okay.
author, he's professor, he's a medical science professor. He's 70-some year old. He said the next revision should not be done by him, so he's gathering a team. By the way, there's one thing some of you might not know. You want Chinese resources, go to Christianity Today. Many of the articles are translated into Chinese and put on the web. If you subscribe
Oh,
to
wow.
Christianity, you have Chinese, Spanish, English for some articles. And one of the latest, which George Sorensen sent out, is why evangelism to Chinese should start with the Big Bang. Their editor, okay, he formerly, I can give you a bit of history, formerly had his own website, apologetic website, got shut down by China lately. So he became the East Asian editor in Christianity Today.
Mhm.
Because Christianity Today's server is in United States, they can't shut it down.
Good.
So you can go and look through Christianity Today. There are many very good articles now available in Chinese because he's there. He wrote Chinese much, much better than I am, okay? I'm really sorry when I access his site and say, sorry, it's no longer available. I have his book too, How to Use the Internet to Evangelize the Chinese. But Christianity Today is the place. His author name is Gideon, okay? But his own website got shut down. So it's very, very nicely written, specifically for Chinese from mainland.
And when will your translation of Navigating Genesis be done? Well, I
It's
mean,
already-
when will it be available for purchase?
I
You
cannot
probably
answer
don't
the
know,
question. It's all in RTB's communication department. They are in direct contact with the publisher. The first edition will be electronic, mainly for distribution in mainland Chinese. I don't know how they would distribute it, but again, through one of these special websites. They already have the agreement. There will be a hard copy form published in Taiwan by Tendao, which is a very famous publisher. They insisted on publishing it in traditional Chinese. Well, that's their way of doing it. I say, well, you need to publish in simplified Chinese. My manuscript is simplified Chinese. So you're welcome to translate it, put it in the traditional Chinese form, but they're going through the final editorial process on the publisher side. There's no more editorial on my side, okay? I'm done with that. So it's the process. The reason RTB does not want a printed copy because everything will be stuck at the docks in Long Beach. Nothing gets through the docks nowadays. You can have things shipped, they will be stuck there for months. So there are things still that's the reason about a global supply chain. You can't get something from Amazon. They don't know when it's available because they have the shipment, but nobody's taking it from the ship. Okay, that's the problem. So I say, electronically, when RTB want to distribute it electronically themselves, I don't know. You have to ask the people in RTB. I completely transfer that over to them because they know better what to do. But I think once that is finished, everything is cleaned up, they should be able to put it on RTB website and actually, sell it themselves. It's just electronic. RTB can have their own server. It's not very big. There's no pretty diagrams. Okay, just like Hill's original book, there's no pretty diagram. Right now, I'm doing the leader's guide. There's a video to go with it, and that is being dubbed into the subtitles being dubbed into Chinese. That's quite a chore too. But that's getting along. My problem with that is even harder than with the navigating Genesis translation, because Hill is speaking colloquially. So there's some English expression that cannot be duplicated in Chinese. And it's quite a laugh when I read how the mainland Chinese translators translate his English. Because it doesn't translate over. Like you don't touch somebody with 10-foot pole, you can translate that verbatim because it has a different meaning. There's the equivalent Chinese expression for that, but they didn't get that. So, and I have to redo half of it. But I mean, the Lord is gracious. I'm glad to have them because they do help me in some other expressions. But that is ongoing, and we are moving along. And that is a video to do with because of the Bible study, Navigating Genesis. So the Leader's Guide is coming along. The actual Reader's Guide would be available very soon. But then they have a video. That video has to be dubbed into Chinese because they cannot. I don't think they can handle just Hugh speaking in English. They may understand partially, but not entirely.
Randy Lewening asks if there's a link to some of your favorite NASA photographs.
My best suggestion is go to download the NASA app on your cell phone or your iPad, your computer. There is a category called images. You can search all you want, left, right, up and down.
Did some of your videos or some of your graphics come from the NASA website?
I think all of them.
Okay.
I don't create. I think very few are created, from scratch. I might have some diddle them a little bit, added some captions. But although I have a part in creating the graphic, but I'm not the graphics person. Like astrobiology, the left-hand one, I gave some of my input to that. We work as a team. The graphics person really, have a basic science knowledge, but sometimes they can get things completely wrong. Like the spectrum can be completely flipped upside down. And anyway, there are a lot of little things like that. But I became essentially a PR person towards the end, and I review most of the NASA press releases. And you'll be surprised, master's degree science writer and can completely get the science facts upside down. So be careful when you read some of the hypes let out by some of the very famous science writers. They could be wrong if they haven't checked it. One of my worst experience was that when they discovered the Hubble Space Telescope mirror error, a very famous science reporter called me up. For some reason, his phone call was routed to me. He said the wrong thing about the mirror being more convex. I say, no, it's more concave. I'm sorry. He said he's glad to call me up. He got it completely upside down. It'd be very embarrassing if he has to retract that. It's a very famous newspaper. I don't want to mention which one. A very famous site, but they could get a thing because in the heat of trying to meet the deadline, they just read the first sentence, last sentence, throw away completely the middle part. Don't read the discussion. You can come up with any conclusion. Like when they announced Mars, they have discovered carbon, the methane. They say Mars has life. That's the headline. I say, oh no, you cannot have that headline because Mars does not have life. You cannot say Mars may have life, or even is not even okay for me. Okay, they say we discover methane, which may be caused by life. Maybe you have to qualify that. So it's very easily. Don't read all the. I always go back to the original article if they have a reference to that. I don't trust any of the things that are written on the press.
So I'm going to ask a couple of my questions. The material on the surface of the moon that they were looking for or are looking for, specifically, I'm talking about the KREEP. I understand the rare earth elements, and K and P. K is potassium and P is phosphorus. Is that what? Is that what?
Yes.
So why restrict it to potassium and phosphorus?
Well, that's the composition. It's not restricted. They have P altogether. It is really rare for anything on Earth.
Oh,
Maybe
so there's
that. They're not mining potassium specifically.
There are some asteroids or not asteroids, but chunks of rock that are potassium, rare earth elements, and phosphorus.
Yeah, they all have P together. The composition is creep. There's a layer of creep.
I gotcha. Okay.
I don't know whether I can show a backup view graph, but I don't think it's necessary. There's
The
a
other
layer.
question. The other question was that little piece of rock that you showed, so beautiful. It had a little measuring tape next to it that was 1/2 of a millimeter. So the whole thing looks like it's not more than a millimeter and a half. Teeny weeny little piece of moon rock. Is that right?
That's right. That's how much you can put underneath a microscope. Ken can comment on that one if he wants to, but if you want to photograph something, you have cut a very thin section.
Yeah, it was amazing. Amazing picture.
Shine light on it.
Yeah, amazing picture.
There are all these electron microscope picture.
Yeah.
That's very pretty. Actually, the lab here in UC Berkeley, they win a lot of prizes. Not that they did anything except to take the photograph. They just cut thin section of various materials, and they become so dramatic.
Yeah.
I have a picture hanging in my living room, which is a picture of amorphous ice. The scientist actually called Fishzone. He didn't do anything except to shine light on it and take a picture. And he's all over the web, okay? He's selling them because he know how to take the picture. If anybody, one thing you guys can do that can become artistic pictures, take infrared photographs. Now, I thought I have time in my retirement. I never got time. I bought the lens. It's very easily done. You can Google infrared photograph. There's a whole bunch of people into that. It's very, very pretty pictures. Much appreciated by many people. Very artistic. You don't have to do much to it except take the picture.
Well, Cynthia, I think we need to release you from this this burden that you've been amazing, and you've spoken. You just keep going. You're the Energizer Bunny. Amazing. And we've learned so much from what you've had to say. So thank you so much. I'm going to, would you like to close us in prayer, or would you rather I did?
Why don't you do?
Okay.
Doug's got his hand up there.
Oh, Doug. Oh, okay. Doug Kyle. I'm sorry. One last question. Doug, go ahead.
Yeah, sorry for that. I just want to say I was the guy who asked the question about the Chinese materials. My wife is from Taiwan, and she has a sister who is a science teacher, or was a science teacher in Taiwan. So I, for various reasons, I have quite a few friends that are Mandarin speaking, and honestly, it is really hard to find good materials. So I really wanted to say thank you for the work that you personally have done in this area, and also for the recommendations. I think there is just an enormous need. I mean, for every one of us, for every one American, at least, there's 4 Chinese in the world. So, the need is just endless to have materials like this. And many Chinese that I've met are very well educated in the sciences. And I just think there's just an enormous need for these kind of materials. So thank you for the work you've done.
You're welcome. By the way, I didn't mention that besides the books I've translated, previously I translated like 5 or 6 articles from today's Reasons to Believe. they're working nonstop to try to create a Chinese version of the RTP website.
Wow.
Okay, just like today, for certain articles, there will be a tag for selecting English, Spanish, or in future Farsi. For certain RTP articles, online articles, they're working towards that like a frenzy, but they need funding. By the way, anybody who hears me, I am, I don't need much funding, okay? There are people who really have to be paid to work on that. And I think the Spanish website is almost ready to go, but the Chinese website, I gave to them last year, but they still, because they're very limited resources.